welcome to the seventh session of the GATE problem solving. So today I am going to discuss 2021 GATE 2021. This will be the part 1 for the GATE 2021. First we are going to the general aptitude questions. Then we move on to the physics problems. Okay, so the first problem this is which of the above sentences are grammatically correct. This is to pick up which one is grammatically correct. But here 1 and 4 Arun Sam is correct. Okay, second question, the mirror image of the above text. This is little tricky. Axis. So if you put a mirror here, S is little tricky. S goes this way. S. Since this goes this way, yeah, this should be the line. Yeah, if you compare this with here, option B is the correct answer. Next one. Two identical cube-shaped dice, each with faces numbered 1 to 6 are rolled simultaneously. The probability that an even number is rolled out. Okay, you have two dices, and what is the probability that you will get an even number on both dices? So there are how many possibilities are there? 36. So each dice has 6 sides. So 6 into 6, there are 36 possibilities. And even only there are only 2, 4, and 6. On each dice you can have 3, 2, 4 and 6, so that will give you 3 into 3, 9%. And the total probability for obtaining only even number is 9 by 36, which is 1 by 4. Question 4. So this and these two are two operators on numbers P and Q such that so they are redefining the operations. P minus Q, which is a difference, they denote in this fashion, and P into Q, they denote in this fashion. So just the question is to identify what is the final answer. So basically replace everything with the corresponding things, and you will get minus 40. I'm not just do this. Next one, the fifth one, the 4 persons P, Q, R, S are to be seated in a row. R should not be seated at the second position from left. The number of distinct seating arrangements. Okay, so let's check the other way around. Like how many number of possibilities are there in which R is on the second position from left? So if you put R here, then P, Q and S can be here. If any of them is fixed, then there are other 2 possibilities here and another 1 possibility. So that means 3 into 2 into 1, which is 6 possibilities are there with this combination. Again, they are asking for total number of possibilities, right? So excluding this one, this is not allowed. So how many possibilities are there in total? 4 into 3 into 2 into 1. So this is 4 factorial, which is 24. So 24 minus 6 will give you the occurrences in which R is not in the second position from left side. So that is basically 8. So next problem. On a planar field, you travel 3 units east from a point O. Okay, so this is, I think you need directions. So if you have north, south, this direction. Okay, so this one is your west, little from east to west. Okay, I'm little confused. Let me check my compass. Okay, my compass is also not working. So let's start from I think this is east. Okay, let's go this way. On a planar field, you travel 3 units east. Okay, so you start from O is this point. Start from point O. Next, you travel 4 units to south. 1, 2, 3, 4. Then you travel from P in northeast direction. So northeast will be this direction. How many you travel northeast direction such that you arrive at point 6. That is 6 units east from point. Okay. And 6, you are arriving at this point, which is from O. It is 6 units away from O and R are 6 units away, and you arrive at this point by traveling northeast from this point. Okay, you traveled in the northwest direction, which is again this direction, so that you arrive at point Q, that is 8 units north of point P. Okay, so basically 1, 2, 3, 4 units and 4 units here, so total 8 units here. This is O, and last one is Q. Okay, so the distance of point Q to point O in the same unit should be this should be 4, right? Okay, where did I make a mistake? 3 units east from point O. Okay, this is 3. This is 3 only. Okay, I think let's skip this question. C is the right answer. Just try out. This kind of questions are little for me at least. The next question also, this is again which of the following is true. I just go to 8 also. I am skipping similar kind of questions. I don't want to waste time this kind of questions. Question number 9. In the figure shown above, PQRS is a square. The shaded portion is formed by the intersection of sectors of circle with radius equal to the sides of square. Okay, R will be the radius of both this circle and this circle. The probability that any point picked randomly will be within the square falls in the shaded area. You randomly pick a point from this square that will be inside this. Okay, that will be basically what's the total area. Total area of the this is basically r square of the square, and how much is this area? So area of the shaded region divided by r square will give you the probability. Let's see how to do this. Basically the idea is to get the area of this thing. So this area you can represent as this thing, this circle minus this area under this particular region. Okay, so this is basically it's a quarter of a circle with radius r. So that is pi r square is the total area of circle, and 1/4 pi r square by 4 will be the area of this portion. And this is basically you have total square minus this one quarter of a circle, right? So that is basically r square minus pi r square by 4. Okay, once you get that, then what will be this area? You have pi r square by this minus this a minus b. So pi r square by 4 minus r square and plus pi r square by 4. That will give you pi r square by 2 minus r square. Now the probability is basically a minus b divided by r square, which is pi by 2 minus 1. So you get the right answer, option C, pi by 2 minus 1. Okay. So this is the last question for the general aptitude. In an equilateral triangle PQR, side PQ is divided into 4 equal parts. So you have an equilateral triangle, so all of them have the same side. All sides are the same. PQ is divided into 4 parts. So I am dividing this into 4. QR is divided into 6 parts. I am dividing this into 6, and PR is divided into 8. So this is 8. The length of each subdivided part is in centimeter is an integer. Okay, so what is the minimum area of square of the triangle? Okay, so we have, if L is the length of each side, then L by 4, L by 6, L by 8. These are the segments. Okay, so the condition is that these are all integer. This happens first time when this is 24. All the other multiples of 24 also satisfy this, but 24 is the smallest number. So in that case, what is the area of triangle? So how to get that? Basically area of triangle is half bs. B is the base, h is the height. So base is anyway here, it is a length L. H you have to get. What is h? So from this triangle you have this is 60 degree. So you will get this 12, half of the length, and this 24, then that will give you this 12 root 3, because it's a right angle triangle. So you get half times b is 24 here, and h is 12 root 3. So that will give you 144 root 3. Okay, so the answer is 144 root 3. So I am then done with the general aptitude questions. I am moving on to the physics questions. First question, choose the graph that best describes the variation of dielectric constant epsilon r with temperature in a ferroelectric material. Okay, so ferroelectric materials, you might have heard about ferromagnetic substance. So ferromagnetic means if you apply a magnetic field, it will be suddenly, like for example iron, etc. They will get magnetized. They will have a permanent magnetization, and even if you remove the magnetization, the chunk of the material remains in that magnetized state. So these kind of materials are called ferromagnets. Ferromagnets have this property of phase transition from once you heat ferromagnets, their ferromagnetic property will lose, and at a particular temperature Tc, they become at a particular temperature Tc, they become paramagnets. So this transition is there is a phase transition between ferromagnetic to paramagnetic phase. This temperature is called the Curie temperature. Okay, similarly, ferroelectric means if you have a material and if it is such that if you apply an electric field, and that will the electric field will be like kind of retained in that. Even if you remove the electric field, there will be a constant. There will be a permanent instead of magnetization, there will be a electric polarization. The chunk of material will be polarized in that particular applied electric field direction. Even if you remove that electric field, that polarization will remain the same. Such materials are called ferroelectric. These are not very common because of the fact that it's not easy to like sustain polarization in a magnet. In the material. These are at least not very common kind of material. So the question is that if you change temperature, what is the dependence of epsilon r? It's relative dielectric constant or relative permittivity. Okay, so first thing, honestly I have not learned about such a thing in any of these like master's or degree level papers. I have heard about this in ferroelectric materials are actually mentioned in the Griffiths book if you look at this, but these phase transitions are not at all covered in any of the syllabus. So how to even such that case, is there any way to like guess this kind of questions? So the first point that you can remember, this is already there. We learned the relative permeability, the dielectric constant epsilon r is given by 1 plus chi e, where chi e is electric susceptibility of the material, such that P is polarization, E is electric field, then P equals chi e. So these are linear dielectrics. So chi e is called the electric susceptibility. If you know chi e, then you can get what is epsilon r. So first point to note is that chi e decreases as temperature. This is natural, like compared to the ferromagnetic objects. If you like permanently polarize a ferroelectric material, then you heat up the material. Usually what happens is that compared to the ferromagnetic object, these atoms will gain more kinetic energy, and eventually they will lose their this polarization direction. Right. Finally, they will, like in the paramagnetic situation, they will arrange in a direction. They will arrive at a situation where there is no net polarization in that material. So what that like this case, what does that means? Chi e should be decreasing as if you heat up the substance as you increase the temperature. So that means if you look at these plots, this one and this one, there is like when you increase the temperature, here actually there is no variation happening. So change in epsilon r will be captured by a change in chi e, right? That's why I am guessing this. So these two are unlikely. This is not going to happen because chi e is expected to decrease with temperature, and there is a phase transition again actually in this kind of material. This actually I got by googling. So option, if you look at option D, this is not a typical phase transition curve. Like phase transition happens when there is a like non-analytic kind of behavior in the parameters like this. So kind of goes like this. So this is usual for a ferromagnetic kind of transition of ferro to para, and here also there is a phase transition happening. So that means this you can confidently go with this option A. Okay, so I'm just trying to like whatever information you have, you can somehow combine to get some options. even if you know exactly the right answer. Okay, so that's it. uh, Next problem. A matter wave is represented by this. Yeah, this is not quantum mechanics, but just wave. It's a wave. Where a is a constant, the unit vector representing. Sorry, representing the direction of propagation of this matter wave is. Okay, actually I found a mistake in the options. So for any plane wave, this should be the general form, generic form. A plane wave propagating in the direction k, vector k, in the direction vector k. So if you compare this standard form with the given form, you actually has k dot r equals 4x plus 3y plus 5z here. This is here. Now that basically you can write down in a dot product fraction, right? If you can write it down as 4i cap plus 3j cap plus 5 cap dot xi cap plus yj cap plus zj cap. So this is your position vector r. So that means this is your vector k, the propagation vector. Now what is the direction? Basically it is not a unit norm vector, so you have to normalize it. So 4 square plus 3 square plus 5 square root 50, which is 5 root 2, which is actually the factor here. Yeah, okay, so I think I missed this 5 here. Yeah, then it's fine. So you have actually but 4 by 5 root 2 here, this one x cap, and 3 by 5 root 2 here, and I actually missed this 5. So 5 and 5 will cancel off. So this is actually correct. There is no mistake in the options. The z component is 1 by root, which is true. Okay, so that's how you get the propagation vector. You just compare with the standard form, e to the power I k dot r, then find out what is k. Okay, next one. Consider a solenoid of length L and radius r, where r is very much less than L. Steady current flows through the solenoid. Magnetic field is uniform inside, so this is fine. And 0 outside. Among the given options, choose the one that best represents the variation in the magnitude of vector potential a phi at z equals L by 2. So this is your z axis. So you are moving in this fashion. Z equals L by 2. At z equal to L by 2 as a function of radial distance. You are moving around. You are moving from here to here like that. You are moving outside the solenoid. What will be the variation of a phi? A phi is the phi component of the magnetic vector potential A. So magnetic vector potential has this relation vector B. The magnetic field is given by curl of magnetic vector potential curl A is B. So we know that inside the solenoid B is constant. So constant along this direction. So that means this curl A should be a constant in z direction. Now they have given this form for curl F, so using that, actually we know that inside since this is only in z direction, the magnetic field, so only this will survive here, right? So this will be 0 if you put A instead of F. That's what I'm saying. And then this will be magnetic field B, this will be 0, and this will be because there is no radial and phi components, so only z direction is there. So this is only non-zero term, which is equals your mu 0 ni, a constant. We also see that there is no radial component for magnetic field because it's only in z direction. So Fr is 0, this is also 0. So we are end up we only has like 1 by r dou by dou r of r a phi is a constant there, only this term. So that, what does that mean? What is the variation of a phi? So this is possible if a phi equals a phi proportional to r. In that case, like this will be dou by dou r of r square proportional to some, there is a constant will be, that will be 2r, and that r and 1 by r will be cancelling off and you will get a constant. Okay, so that's how you can guess that inside the solenoid the AFI will be proportional to r, so it's a linear in radial component. So both this one and this one are possible in that case, but you have to, now you have to look at the what is outside. So outside it's actually easy to guess, like anyway if you move around away from the source, any fields, whatever it is, it's a magnetic field or it's a vector potential, it will be decreasing. Here actually this is not physically possible, like it remains the same throughout, so you can simply neglect this option, so this is not possible. So the leftover is only this option C. So it increases linearly till the radius capital R, then it decreases in this fashion. Okay, actually I think this variation is like 1 by r, it goes like 1 by r. Anyway, it's not important, but this is how you get this. So you identify that magnetic field is curl A, then using the curl F in cylindrical coordinates relation, you basically find out what is the variation inside this one. Okay, next one. This is just to pick up what is correct statement. So silicon is direct band semiconductor, which is not true. Silicon is indirect band gap semiconductor. So this is not true. Conductivity of metals decreases with increase in temperature, which is true. You might be remembering this in E squared tau by m, where n is the number of charge carriers density, E is a charge of electron, m is a mass, and tau is a relaxation time. Tau is the important quantity to note here, relaxation. Okay, so if you increase temperature, what happens? The molecules jiggle very drastically, more often, or the relaxation time decreases. So temperature increases means relaxation, they cannot relax anymore. So relaxation time decreases, that means your conductivity is decreasing. So as conductivity of this is true, as you increase temperature, your conductivity decreases. Conductivity of semiconductors decreases with increasing temperature, which is actually not true. This is a case for metals. Semiconductors, what happens is that as you increase the temperature, more charge carriers come into the conduction process, then their conductivity actually increases. So this is not true. And gallium arsenide is an indirect band gap, which is not true. Gallium arsenide is a direct band gap semiconductor. Okay, so option B is the only right answer. Next one. A material is placed in a magnetic field intensity H. As a result, bound current density JB is induced and magnetization of material is M. The magnetic flux density B. Choose the correct reference valid at the surface of the material. Okay, so like maybe you can cylinder or something, you have a permanent magnetization inside. So they are asking about what happens in the surface like that. So del dot M equals 0. So okay, del dot B equals, this is always true because there is no magnetic monopoles. So this relation always and everywhere true. Del dot B is always 0. So this is true. Now M, the magnetization is given by B by mu 0 minus H. So del dot M is basically del dot B by mu 0, which is 0 minus del dot H. So del dot H equals del dot M. These can be non-zero. For example, here, if you take this point, where actually there is a a divergence in the magnetization vector. So if you have vector coming in and suddenly at this point it is vanishing, so that means it's going inside. It's kind of a divergence means it's a kind of a sink or source. So if you might be remembering, like in the case of electric field from a point charge, either it all converges to a point, or in this case divergence is non-zero. So similarly in this case there is a divergence here in the surface. So this is in general not on a surface is always like it's not zero on the surface. So they are asked things what about on the surface actually. So that's why del dot M, and hence del dot H is not zero. What about the last option, del dot JB? So JB is the bound current density, which is given by JB equals curl M. So taking the divergence del dot curl of M, which is again always zero due to the fact that curl of a divergence of a curl is always. So a curl cannot diverge. This is also true always. So that gives us option B and D are true at the surface of the material, and A and C are not true because of this fact, because there can be a divergence in the magnetization M as well as X. Okay. So next, for a finite system of fermions where the density of states increases with energy, the chemical potential. Okay, again, to choose which of them are right. So this is actually a relation for fermions. The chemical potential at a finite temperature T is given by E minus E is the Fermi energy actually here, minus pi square by 6 kBt square. So roughly there is a constant here sitting here, but you only want to look at we only want to look at the temperature variation, right? So this is fine. So the idea is that this is a constant Fermi energy, and you actually, as you increase temperature, this actually decreases. So with temperature, Fermi the chemical potential decreases. So this is true and this is wrong, and this is also wrong. There is a variation with temperature correspond to energy where, yeah. So now you have this distribution function, Fermi Dirac distribution 1 by e raised to minus E by E minus mu by kBt plus 1, where E is the energy and mu is a chemical potential at that temperature. So at any temperature you can see that if you put E equals mu, you will get 1 by e raised to 0 plus 1. E raised to 0 is 1. So that will give you n is always 1. So n of E equals mu equals half for any temperature. This is true. So that's why option D, which means corresponds to chemical potential corresponds to the energy where the equation probability is always half. So that is also true. Okay. So A and D are correct. Another one, true or false kind of question. To sustain lasing action in a 3-level laser as shown figure, the necessary conditions are: A, lifetime of energy level 1 should be different. So you have a 3-level system like this, 0, 2 and 1. So this, if you remember, this should be a metastable state. So normal temperatures, this will be the ground state. So you have high probable occupation in the ground state, what you do is you invert the population by bumping to second this second, and I mean the third accelerator set, this 2 mark 2 here, then they will suddenly decay to 1, so that will be creating a population inversion. Suddenly, like the population in 1 will be higher than that in 0. So then any like a single photon ejected will cause uh, the stimulated emission in all the other atoms, causing a lasing action. Okay, so lifetime of energy level 1 should be greater than that of energy activity. So this should suddenly decay to this. So 1 is called the metastable state. It should be having higher lifetime than the other states. So population of the particles in level 1 should be greater than that of 0, which is of course true, because that is called the population inversion condition. Otherwise, what happens is that if population in 0 is higher than that in 1, then more absorption. So stimulated emission and stimulated absorption. Both are actually having the same problem. So whenever a photon comes, it can either take it upside or downside. So depending on which one is more occupied, you have that kind of transition. So given that you have more particles in the lower ground states, so stimulated absorption will happen. That will kind of like absorb the energy. Now if you have population inversion, then only you will get a lasing action. So population of the particles in level 1 should be always should be greater than 0. That in level 0 to have the lasing action. So lifetime of energy level 2 should be greater than that of energy level 0. Energy level 0 actually does not have any lifetime, because it cannot decay down. This is not true. So population of the particle in level 2 should be greater than that of level 1, which is also not true. Like at any instant, it's roughly like 1 will be having more population, then only you will get stimulated, lasing action. So only A and B are true. Okay, so next one. If In of x is a solution of the differential equation, y double dash minus 2xy dash plus 2y equals 0, and is an integer and prime denotes the differentiation, then the acceptable plots of psi n of x equals e raised to minus x over y n of x. So y n of x are the solutions. So this is actually straightforward question. If you identify that this is basically Hermite polynomial equation, Hermite polynomial differential equation. The simple harmonic oscillator is basically, if you arrive at the differential equation, the Schrodinger equation corresponding to Schrodinger simple harmonic oscillator basically takes this form in the position basis. So that basically, if you should be remembering the ground state is a Gaussian state like this. State, Gaussian wave function, and also there is a fact that all these states are orthonormal. Orthonormality. That means if this ground state is an even function, if you put x equal to minus x, you have the same value. Then your excited state, first excited state, should be odd function, because otherwise it cannot be a orthonormal, it cannot be orthogonal. So this one is the first excited state actually, if you remember the state. Now this is not true, option A, there is no variation at all. This is no way orthogonal with respect to this option and also this one. But actually, it's actually orthogonal to option C, but not with respect to B. So this should be having a set of all the eigenfunctions are orthogonal with respect to every one else. So this is not true. Also in this case, this is a straight line. This one and this one are not orthogonal. Okay, so moving on. So only B and C are if vector A, vector B are constant vectors and vector R, vector P are generalized positions and conjugate momenta respectively, then for transformation Q equals A dot P and P equals B dot R to be canonical, what should be the value of A dot P? It's an integer. Okay, so we have that if a transformation, so a canonical transformation means you start from old coordinates. This is your old coordinates. So by some transformation generated by something called generating functions. You end up with new coordinates, new canonical coordinates, which will be some functions of old coordinates. These are all also canonical conjugate variables. So this is called the canonical transformation. So before and after, the important point is that this condition should be holding. So that is the only thing we have to remember here. So we put that QP, capital QP is 1, and then substitute for Q and P. Q is basically A dot small p and P equals B dot R. So what they have given is that A is just a constant vector and P is a set of it's a vector of all generalized coordinates. So for example, P1, P2, P3, there can be a Pn coordinates. For example, can take any number, it's a general case. Even n can be 1, that will remain in 1. So this integration summation basically goes from n equals 1 to n. So this is basically some more AI PA and some more BI RI. RIs are the such that this is like individually they are RI PA. These are the canonical variables. Okay, so putting that here, just evaluate that Poisson bracket. This is the definition of Poisson bracket. You have some more I, dou by dou I. The first term you differentiate with respect to canonical coordinate, and the second term you differentiate with respect to momentum. Now put a minus sign and reverse this differentiation. First term with respect to P and second term with respect to R. Okay, now this is 0 because these are canonical conjugate variables, so Pi does not depend on Ri, and this is also true in the same footing. Now there is a minus sign and summation over I. So here actually what happens, so all this will be false, like dou P2 by dou P1, and similarly these all will be 0. So that will give you only ith term here. If you are differentiating with respect to ith term, then you will get only ith. So there will be a AI here. So in this summation there will be only AI here, but this summation is still here, and that summation is this one. So sum over I minus AI, and also here you will get BI. So that means sum over AI BI equals minus 1. So now if you identify this is basically a vector A dot vector T. Okay, so that means A dot B is minus 1. So the answer is minus 1. Okay. Next problem. above combination of logic gates represent the operation. This easy, very easy question. If you remember De Morgan's theorem, so a b all bar is a bar plus b bar. So you have, this is an OR gate, this we have here, and individually there are NOT gates. A dot or E dot is basically a b all bar. Okay, so this is basically a De Morgan's theorem. You also have the another De Morgan's theorem. A plus b all bar is basically a bar b bar. So this will result in similarly like if you have, so this is a bar b bar. If you have an AND gate, it nots. So this will correspond to a NOR gate. As this is an AND gate, this is an OR gate. Okay. Next one. This is a problem from actually little. You need some advanced knowledge to. If you have that, you can actually answer this very easily. Consider spin as equal to half is equal to h squared by 2 is a spin half particle in the state phi equals 1 by 3 2 plus I and 2 the state. The probability that measurement will find the state at sx equals plus h. So sx is basically polymetric. You can have either plus h squared by 2 or minus h squared by 2. These are the two possible states. So usually we denote them as plus and minus states. Okay, so the first check you have to do in any kind of this problem, you check whether the state is normalized. Otherwise you cannot get the probability. If it is not normalized, you have to normalize it. So taking the phi get phi bra phi, you will get 1 by 9 2 plus I conjugate and plus 4 because of this 2 times 2, that means 1 by 9 times 9, which is 1. Okay, so it's a normalized state. You can carry forward the other calculations. Now what they have asked is what's the probability to get the outcome as x equals plus x. So the only technical knowledge you have to be here is that the plus state is this state. So this is the plus 1 eigenvalue state for the Sx operator, the poly x operator. So actually I don't know whether you have learned this. I just give you the states. So the Sz poly Z actually has this state 1 0 0 1. So this is the plus x squared by 2 state, this is the minus x squared by 2. These are standard notations. Sx has this poly. Okay, so the matrix also I will just write 1 0 0 minus 1 times h squared. There is a h squared by 2 fact. Because the spin these are not polys, these are spin operators. Just they have an additional h squared by 2. That's it. So 0 1 1 0. This is a poly the spin operator. And these actually has the eigenvectors 1 1 and 1 by 1 minus 1. So this is a plus h squared by 2 state and this is a minus h squared by 2 state. Similarly, the y matrix 0 minus I 0 sy. This is a poly sy times h squared, the spin operator, and this has the states 1 by 2 times 1 I and 1 by root 2 1 minus I. cut by 2 and minus. Okay, so these are the three poly matrices or three spin operators and the corresponding plus and minus eigenstates. These are the eigenstates. Okay, and the eigenvalues. So here what they have asked, this is the corresponding to this eigenvalue, which is this. That is the probability. Now if you know the state, just take this projection plus plus and get phi, and take the absolute square to get the probability. That will give you 1 by 3 root 2. 1 by 3 is coming from here and 1 by root 2 is coming from here. Then you just take the inner product, you get 2 plus I plus 2 modulus square. So since it is a modulus square, it is 4 plus I modulus square divided by, in the denominator you have 9 times 2, which is 18, which gives you actually 4 plus I into 4 minus I is 17. So you basically get 17 by 8. That's the answer. So the only thing you have to remember is this standard notations of what is a plus state and what is a minus sx plus state, sx minus state, and similarly if you want sy minus sy plus, etc. Okay, so that's it. Let me see how much time. So the question, as shown in figure, X-ray diffraction pattern is obtained from diatomic chain of atoms P and Q. The diffraction condition is given by A cos theta equals n lambda, where n is the order of diffraction T. A is the lattice constant and lambda is the wavelength of X-ray. Assume the atomic form factors are resolution do not depend on theta. Then the intensity of diffraction peak is. Okay, so there are 4 options given. Which one is true? Okay, so the idea is here you have 2 types of atoms, and there is a diffraction pattern happening due to both, like A and B both can cause this. Now if you take this kind of a setup, this length is A, from A to the next same kind of atom, this is A, also from B to the same kind of B. Now it's like so this much distance, this is the path length, path difference between the wave diffracted from this atom and this atom. So the path difference between them causes interference, and that decides whether you have a constructive or destructive interference at this at the receiving point. Similarly, you can see there can be waves coming from this atom and this also. That also results in some. So at the end, they all mutually interfere and get the pattern. So the thing to note is that if you have even number of if cos theta, a cos theta is basically this the path difference between them. If a cos theta is n lambda, when n is even, you basically have like this is 1, this is 2 and 3, 4. So you have 4 cycles, for example. This is just an even number. So in that case, basically whatever you B is radiating out the refraction and the one radiated by A, these are in phase, right? Because they align up basically. So after two complete cycle, the cycle from B is also starting. So like that. So this will, when one is finished, this one will start. So they are in phase. So whereas if there is an odd number of when a cos theta is odd, then you have basically like this that is an odd number. So that means when this is half the way, so that's the portion. This is the half the way. Now B starts to radiate out in the same point. So that means these are now out of phase. So this one and this one, these are out of phase. The one radiated by A, the one radiated by B, these are out of phase now. So that actually results in a destructive interference. But since these are two different atoms, they are like the amount of radiation they are radiated out is need not to be the same. The intensity need not to be the same. So that means there can be some intensity, but not perfectly dark. If they were the same atom, then it should have resulted in a destructive interference or absence of a intensity peak. But since they are two different atoms, there can be a slight intensity. So that means now if you look at the options, 0 for odd values. So this was the case when if all the atoms are the same. Since it is not the case here, you cannot say that. So that means lower for odd values of n when compared to even values of n. When n is even, you have constructive interference and you have maximum intensities. But when n is odd, you have lower value for odd, lower intensity for odd values. So I think that's the idea is clear now. Moving on to the next topic. Okay, so as shown in the figure, two metal semiconductor junctions are formed between an N-type semiconductor S and a metal M. The work functions of S and M are phi S and phi M respectively. Phi M is greater than phi S. I think these are not much important with respect to this particular problem. So the junction is like this: you have a metal, you have a semiconductor, again you have a metal. So semiconductor is N-type norm. What is the IV characteristics of this junction? Okay, so if you remember the usual PN junction diode, you have a P-type and an N-type. You connect your battery and you look at the IV characteristics. So you have voltage here and I here. So as you, if this is positive, if this is positive and this is negative, then you have conductivity. This is like there will be barrier potential here. The moment you cross that barrier potential, you will get suddenly you will get a conducting. Whereas in the reverse direction, if you switch this to negative and positive like this, then you basically reverse bias the diode and you will get there is no conduction at all. The conduction will start when you have breakdown. The diode will be no more functional and breakdown will happen, and there is a asymmetry between positive V axis and minus V axis, because there is a P type and N type kind of heterogeneous junctions, whereas here you don't have that heterogeneity. It's only always a metal semiconductor and semiconductor metal actually does not matter. This is if you have these are metal wires and this is just a metal junction. So basically you can consider it as you connect a semiconductor junction to a cell, that's all. So this metal does not add anything, if I would say. So that means you have, now what about this plots? If you have positive voltage, you will have positive current. Now if you reverse the voltage, again there will be a junction is, the semiconductor is always having charge carriers, N-type charge carriers, electrons. So anyway there is a current flowing. So if you reverse the voltage, the current will be flowing the other way around. So In that sense, this cannot happen. Here, whatever the voltage, positive or negative, current is always positive. So this does not happen. And also there is no asymmetry between whether you have positive voltage or negative voltage. So in that way, this and this both are can rule them out. So the only possibility is this is basically a symmetric kind of graph. But the moment you reverse voltage, you actually get a reverse current also. So that's the only thing about this problem. So okay, we have I think one hour is. Okay, I will next in the next session I will start from here. Okay, so yeah, thank you.